And we're on. Cool. So, we've got this big complex electrical system so far. What you're looking at here, with the exception of what I'm about to discuss, it doesn't matter what you apply it to. This really is the high voltage system. If I couple this motor, or this inverter, and this inverter to a gasoline engine through a planetary gear set, that's a Toyota Prius, that's all it is. That's the entire complexity of the Prius. Not much, is there? Really?
Is that why they were garbage?
They're great. They'll last 500,000 kilometers or more. They're wonderful cars. If you like the Ford hybrids, same thing. If we take away the gasoline engine and we want a dual motor, all-wheel drive car, there it is. We can lift this diagram and apply it to most electrified vehicles. If we want a third motor, we have to apply a third inverter. If we want one motor, we take the inverter away. If we don't need to heat the battery, we take the battery heater away. If we want to cool the battery, that's done with the air conditioner anyways. This is your basic operation. We haven't looked at the charging system. It's way down here. Today I don't want to look at the charging system. I think I've given you enough to digest already. There's lots to this, right? When we get to charging, and it's right after batteries, when we start to discuss those, then we'll add it to just the battery. We'll take away the rest of the complexities of the system, okay? The last thing I want to talk about, we go right back to this little devil right here, this capacitor. Capacitors are incredibly efficient at taking in energy. They're also incredibly efficient at giving it back. When I shut off the car, I get rid of all that energy. Capacitor goes to 0 volts. It is now empty. How quickly can you fill an empty cup? The neck of the bottle is usually the limiting factor, right? So if you got a wine glass, you can fill it like that. But the limiting factor is the wine bottle. It slows everything down. Well, the battery has no neck on it. It's huge. It's a great big open bottle. It's a bucket. How quickly could I fill a wine glass from a bucket? Instantly. Do I risk damaging the wine glass? I could knock it over. The pressure coming down on it could shatter it. Right? The wine glass can hold wine, and it's good at giving me wine quickly. And I can refill it pretty fast. If I try and fill it too fast, I destroy it. I blow it up. In this analogy, that's the bucket, and the capacitor is the wine glass.
But can you overfill it?
No, you can't overfill it. Because the wine glass in this instance can hold more than the bottle. The wine glass will be, if this is a 400 volt system, it's probably 650, 700 volts. So it actually has more capacity than the source because of the regenerative nature of this. How much energy can you put out of an alternator? How fast can you spin it? Right? We can't vary the size of the magnet in this thing. It's fixed, it's a known value. So if I'm going super fast and I put it into maximum regen, I can actually make more energy than the battery has. So I'm going to store some of it here and then give it to the battery slowly. So this is a big wine glass. But if I turn it on, it's the speed, not the pressure. It's the speed of the electricity hitting it. That's what I'm worried about. Okay? So I have to control the speed that I apply power to that capacitor. If I just open the contactors, is there any resistance in a contactor when it's closed? Nope, shouldn't be. A great big cable, that thick, is there any resistance really in that cable? Not really. So it's going to fill that glass quick. I gotta have a different way of doing it. I gotta slow things down, right? We gotta put on the mood music. Maybe a little bit of Seal goes on. That's a real throwback there. We dim the lights a little bit. We gotta slow things down, right? All right, so I'm gonna do it, and I'm gonna do it with another contact, another circuit. we're gonna add a circuit to the battery. And I'm doing it on my case. And this circuit is what we're gonna call a pre-charge circuit. It is going to activate when I first start the car in order to regulate the flow of current into the capacitor so we don't overwhelm the capacitor and blow it up. So we don't overwhelm the circuit and blow it up. The pre-charge circuit is going to bypass one of the main contactors. So this pre-charge circuit can be on either side, positive or negative, doesn't matter. It all depends on what the manufacturer felt like doing that day. There we go. So come down. The very first thing we're going to hit what's that? Resistor. It doesn't have to be a huge resistor. It might be 20 or 30 ohms. When we're talking about high voltage, that's not a big resistance, right? So we bypass, or we hit that resistor, and we go ahead, we enter into another contactor. And yeah, the contactor is not as big as the OG. Does it have to be? No. There we go. When we start the car up, we press the button. It's going to do a self-test. It's going to figure out if one of these things is stuck closed. Toggles them one at a time, whatever the manufacturer decides they're going to do. I've got an example in the contactor thing when we talk about the construction, but everything looks good. The next step it's going to do, it will close the main negative in this instance and the pre-charge contactor. When I turn the car on, how many volts does the battery have? 400. When I turn the car on, starting from fresh, how many volts does the capacitor have? 0. Is there a pressure difference between 400 and 0? Is 400 bigger than 0? If I just apply power, I would get what they call inrush current. Somebody dumping the bucket on the wine glass. I got to put a neck on that bucket. Pre-charge circuit's going to be that neck. So this pre-charge circuit will remain activated until my potential is equalized inside and outside of the battery. Until 400 volts here and 400 volts here, all the way down. How long do you think that takes?
Seconds?
Milliseconds. When you start one of these cars, you'll hear click, click, click. It's just contactors firing away. Here we go. Test, pre-charge, main. That's it. It's a little bit more clicky, but click, 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 click. And it's just that fast. But that is enough to slow down the current entering into all of those electronic devices in order to keep them safe. A pre-charge circuit reduces the inrush current. Inrush current applies when you have a power differential. It's the current rushing in. Okay? So a pre-charge circuit controls inrush current. Once the system is equal, we got 400 volts in the battery, we got 400 volts in the high voltage system, it will close the main positive and open the pre-charge in this circuit. And then it's ready to go. Whatever the motor needs can go through this circuit unimpeded. Can return to the battery unimpeded. If the pre-charge circuit is open, could the inverter see that? So, say you've used your battery, use it, and this resistor snapped. Oh no! If we apply the pre-charge circuit, can the inverter tell that it's not pre-charging?
Yes.
Yeah, because it's got the logic circuit in it, right? It's measuring for 400 volts here. It knows, because the BMS and the logic over there, they talk to one another. They're on CAN communication all the time. Battery goes, I'm trying. And the inverter goes, I don't see nothing, bruh. It's taking too long, bruh. Right? You're yelling back and forth. Too long to charge. It knows something's wrong. It may not let you fire up the battery, just to protect itself. All right, let's reverse the scenario, or change the scenario. Instead, now there's no longer a resistance there. Oh no, we got a short circuit across that resistor. Could it happen? Maybe, I don't know. I'm not a doctor. Sure it could happen. How long will it take to pre-charge? Will it be faster or slower than the original?
Faster.
Way faster. Bang! 400 volts is right there. Is the inverter going to tell that this charged up way too fast?
Yes.
Yeah, absolutely. It's going to go, oh my God, something went wrong. Pre-charge too fast, sets a code. May not let you start the car. So we're going to monitor for pre-charge time. How cool is that? Are contactors replaceable? Are they a serviceable part in the battery? Yeah, they're just big relays. You can open up the top of the battery and unbolt them. Can I replace the pre-charge resistor? Yeah, it's just a resistor, wires right in. When we see it tomorrow, you're gonna be like, that's it? Sure is, yeah, that's it. That's all the magic we have here, there's nothing else. All right? How cool is that? This is everything really except the onboard charger. We'll get to that. And the plug on the side of the car. Look at that, you guys can all go write your electrician's license now. I wouldn't do that. I wouldn't do that. All right? So, like I said, this is going to be in 4 parts. I'm going to upload it to the internet. I'm going to let you go a half hour early today, because I think we've all soaked our brains enough. What do you think? All right? We've covered a ton of subject material today. What we're going to do now that we've got this base knowledge, as we go through for the next week and a little bit, we're going to break it down. We're going to look at the pieces. Most of the time I want to be in the lab. I don't want to do this a whole bunch. I'll have my whiteboard down there. We'll take something apart. We'll draw it. We'll look at the presentation. We'll look at the presentation. We'll go from there. How's that for everybody? All right? What do you got? When's the quiz? Tomorrow afternoon. All right? Yeah, I'll do a quiz tomorrow afternoon. That's right, 11 o'clock, the afternoon. Towards the end of the day, how's that? What's that? Theory. It'll be 10 or 20 questions, written short answer. Lab? Lab 1 will be probably the end of the week, and then the end of the second week. All right? And we'll do it on the same day that we do our exam. We'll do 2 hours for the exam and then the lab test after. And it'll be one-on-one, you and me. We'll do a little testy, and you'll show me the skills that you have, and the skills that you don't. You're gonna make it through because everybody here is here, right? Okay, perfect. That's it. Sorry? What was? We shut the car down? Yeah, we're gonna do plug-in chargers. We're gonna do that later. Because today, if I started talking about plug-in chargers, somebody in the back would like pull a knife and I'd be over here going, but it's so interesting, right? Won't kick a chair, we'll kick a chair next time. Have a good afternoon.